Hari.
Thank you. Yeah. Greetings. Thank you for joining me. I'm Hari. I'm from India. And this is the first time in Boston. And it's great to be here. The hospitality is amazing. Except for the fact that I did few stupid things coming here. I walked out of the airport with sweatshirt and tracks. And it probably killed me, And later on, I spent an hour in my room trying to figure out how to light up the lamps. It was dark, and I found the knob. Instead of, I was pressing and pulling it out, but I have to turn it. I didn't know that. And got logged out of my room today morning. I didn't know it automatically closes without the card. So these things I was doing. So I'm an Android developer and a UX engineer, and I work for a nonprofit organization called Hubba. And what we do in Hubba is like we are just 1.5 years old, and we are an e-commerce for handmade products made by the rural artisans. So in short, we really use tech to help the poor. And we have generated 8,000 days of employment for them. And we won the Facebook Innovation Challenge grant for a nonprofit organization. And my job is to maintain that big baby to your right. So it's a first time we are trying to do some different thing with tech. Like it's a manless e-commerce store where you can browse, watch videos through that lens. It's like a bioscope kind of a thing. It used to be the old age theater where you watch movie inside the lens. And those boxes you're seeing around, it's like automated boxes which will have product samples in it. And if you're seeing a product in the tablet, open the box opens automatically with nice lights and gives you a taste of the product. So it's like impact, watch, shop, a new kind of an e-commerce experience. So today, we're going to discuss about creating keyframe animations using ConstraintLayout and Constraint Set. And these are the pit stops that we'll be stopping by today. Some intro about the constraint layout, and then we'll be seeing some of the animation examples that I came up for the talk. And to reduce the complexity, we'll be taking a simple example, and we'll be running through it completely. Then some of the frequently asked questions, we'll be taking it up. Some of the questions that people came up with when I was publishing this post. And some other complex examples, few other transitions, and finally some heads up. So before we begin, I would like to understand how many of you have actually used constraint layout or using in your day-to-day layout building. Wow, that's nice. Actually, it's in one of the surveys it said it's the least used library. I'm not sure. But yeah, so a lot of improvements is needed for the constraint layout as well, I agree. And anyway, for others, we'll have a small intro about constraint layout, and you'll have some details to grasp so that why do you want to use it. Let's get into it. So what is constraint layout? Constraint layout, in short terms, you can say it's a powerful relative layout, where relative layout is one thing that is very flexible as well as it is optimizable. And you can mimic any layout containers operation using constraint layout. And the next wonderful thing is it provides flat view hierarchy, where, of course, the designers used to give us all the designs. And definitely the nesting will be there. You cannot avoid it for all the apps. And when you're nesting it, it takes a lot of GPU rendering the preview as well. And there'll be overdraw issues. Well, constraint layout can drastically reduce it to some point and make sure you'll have smooth, clean rendering of your UI. And it's flexible with the layout editor. I'm a kind of a guy like prefers XML. Instead of dragging and dropping, I just quickly type things out of the XML, and that makes my job easier. But when I switch to constraint layout, trust me, the layout, I am not going back to the XML, of course, at a certain point I have to go, but majority of the time, everything just fits right on the screen. And the layout builder is faster, and you can easily provide constraints using the layout editor. And responsive UI. The product that I was showcasing before, I had to work with 18-inch tablet. It's like the Samsung Galaxy View, probably, the 18-inch tablet. And the real estate is so big. So using constraint layout saved a lot of time for me, rather than trying to build layouts for different screen sizes. So you just build ones for portrait and landscape, then it takes care of everything. And let's get into the quick working of constraint layout. So how does this constraint layout work? For every view that is that's been dropped into constraint layout will have some constraints. The constraints will be in form of chains, the positions, the ratio, and all these values will be there that you will be giving it to the particular view. And then these data, imagine it's like a metadata of every view, that will be converted into system of linear equations. And that equations will be given to a solver, which will solve and gives the exact position for the entire, for whichever the screens that you're building, the screen sizes of the screen. And that's solver is nothing but an algorithm called Cassavary linear arithmetic constraint solving algorithm. This solves system of linear equations and inequalities in an effective way. I took this this slide just to make you understand of the animation concepts that we are going to see the next, so that you will understand how this algorithm actually works for the animation. And these are some of the animations that I came up with quickly for the talk. And as you can see, the first thing is like a kiosk setup where you get information out of each other by tapping into Java and Kotlin. You get some text, you read. Next is like an e-commerce kind of a thing where you choose a product, select the size, and then add to cart. Third one is like the speaker profile or the detail view, what we call. You can get information from any of the list out of it. Just for the sake of simplicity, I'll be taking this example to walk you through how this animation actually works. So it's a very simple animation where we have Android mascot on the top, and when you tap on it, it comes to the bottom, enlarged, and vice versa. This process just repeats. So let's get into it. In order to create this animation, I'll be giving you 4 simple steps. First, we'll discuss about the steps, then we'll discuss about the entire walkthrough of the code. So the first step is to create our primary layout, which I'll call it as the first frame, because the word layout, it keeps repeating when I say constraint layout, this first layout, second layout. So let's call it as the first frame, and we create that layout by keeping the initial position. For example, in the animation we saw, the mascot is on the top, providing left, right, and top constraints, and the size of the image view is like 100 dp each. This is the first frame. Then we create the second frame, that is the end animation, how it should look at the end. So the mascot is at the bottom, left, right, and bottom constraints, and the size of the image is like 250 dp. Then the third step is where we programmatically perform this transition. And if you're comfortable in Java, please go ahead. You will find a link, the Java gist. And yeah, Kotlin is here. So this function, the basic function, is we use Constraint Set and Transition Manager and apply the respective constraints. So we'll go deeper into this set of code and we understand. So if I give an abstract thing of the constraint, we use Constraint Set to absorb the constraints, and then we use Transition Manager to help us with the transition. Then we use Constraint Set Apply to apply the constraints respectively from first frame to the second frame. That's what the keyframe is. It's like the moving pictures, you actually do it. So the last step is an important step. Run, that's it. I mean, don't run from here, but yeah, so it's just, that's it. The animation works, trust me. So let's get into the deeper insights of the code, what we are actually using, what is constraint layout and everything. So constraint set, it's a class that you allows to programmatically set the constraints used by the constraint layout. So for example, obviously this works with constraint layout, and you have all the metadata, like the constraints of a particular view. And this constraint set holds the view, and that can be manipulated in different ways. You can apply it, you can absorb it. So that's how the constraint set works. And then we use the functions called load and clone. Both does the operation similarly with slight difference. So constraint set.clone will actually inflate the layout and absorb all the mappings, the constraint mappings of the particular views within the constraint layout. And the constraint set.load will actually parse the XML and get the values out of it. So if you look at the code, we'll be using it, load, to inflate and absorb. For the second layout, we'll be using load just to parse the XML. And transition manager. So transition manager is a class which helps us with all transitions. We can perform custom transitions by inflating, getting the custom transition by applying your own transitions. We can use interpolators, set your own transitions. But yeah, we have used begin delayed transition, which is kind of a default delayed transition method that will help us with. And finally, apply to. So apply to will apply the set of constraints to the particular constraint layout. Whichever ID we are giving, it will apply those some constraints that is holding in the constraint set to the destination constraint layout. And let's get into the actual working. So what we are doing initially, we have a first frame created, and we are using constraint set to absorb all those values, and we are having it in constraint 1. We are using clone to actually inflate it and gather all the constraints. Then second, we are having constraint 2, where we are using load to parse the second XML, the second frame, and absorbing all the constraints and mappings. Then we ask the transition manager to initiate a transition for us. And by having the transition, we apply the respective constraints based on the click value, whether it's in the top or the bottom, you click on it. The second constraints will be applied to first. When it's on the bottom, the first constraint will be applied to the second. So now if you look at the code, so set is nothing but a flag that will just identify us which position we are clicking the mascot. It's on the top or the bottom. We use constraint set 1, clone it, set constraint 2 to load all the constraints. Then we use transition manager to initiate the transition. Based on the click value, the set flag, we are applying the constraints. That's it. That's how this animation actually works. Let's get into the frequently asked questions. Probably these questions you will already have in your mind. And when I wrote a blog post about it, some of the people were asking these questions. So I took some of the nice questions to answer it here, discuss it here. So duplicating a layout for an animation, is it a good thing to do? Duplicating anything is considered as a bad practice, obviously. It's like it's treated as a boilerplate. And duplicating never works. I mean, you'll be pushed saying that you're a bad developer. Well, that's how the world works. So is it a good thing to do? Yes, good question. And this same animation can be achieved in n number of ways. We have object animator, physics-based animations. There are a lot of ways that you can achieve the same animation. Why would I want to prefer this method of animation? And the third question, every layout, obviously this method requires constraint layout. So every layout will have nestings. You will not have the flat view all the time. So how does this method work for the nesting layouts? And finally, the GPU load. How is the GPU load? Because for every animation, people will come up with asking for the GPU load. And for the last question, I can answer directly. The GPU load isn't that much. I measured, at least for the examples that I tried out, it was very little. The spike wasn't that affecting very obviously. So the first question, duplicating the layout. And this question has two answers. For example, if you want to animate only one view for your activity, you can straight away animate that view in the program, such as like this. You use transition manager, you initiate a transition, then I'm just setting a minimum height of 200 for the text view constraint. So that works. And another thing, when I say you're duplicating the layout, I mean, we have 2 frames, but you're not technically duplicating the layout. The second layout, the purpose of the second layout, it is not inflating or it's not used anywhere in your app. Only the values, the constraints are being used. When you use load, it parses the XML of the second layout and it absorbs only the constraints. It is not using the entire layout, inflating the entire layout. It's not coming to the user in point of view. So only the values are absorbed. So you're technically not duplicating it. You're creating a file, obviously, and that constraint set.load will absorb all the values, not the entire view is getting inflated. Why this animation? A very good question. So we have n number of methods to accomplish this same animation. Why do you want to go for this method? So the first thing, yeah, the obvious reason. If you have UI built with constraint layout, yes, you can try this method. And as you saw, less code, less time, less math. I'm a kind of a guy who loves layouts, animations, but kind of not good with Max. Let me rephrase that. Max hates me. So I'm trying so hard to be good for Max, but it's not going easy on me. So when you are feeling uncomfortable with mathematics, please do try this method. You'll love it because the living proof living here. And when you have too many views to animate in a single event, so this method is quite effective. because you can just do it in 10 minutes and focus on the thing that you'll want to do actually. So in nested views. So how does this work when you're nesting a view? So the nesting views, the animation obviously can be achieved, but you need to put little additional efforts, such as this. You create the main frame, the first frame, using the nestings. Put all your stylings into that frame. The second frame shouldn't be nested. It should have only constraint layout as the root layout. And then you initiate the transition. For example, let's take this example. It's like the e-commerce example, where this is the first frame. This is how the first frame should look. I'm putting the constraint layout inside the card view here. And this is the second layout, where I'm not including the card view. I'm just keeping the constraint layout as a root. And then this animation, that's how this animation works. So for the nested views, you need to focus on the particular animation, the constraint layout, which you want to animate. And you produce a replica of the second layout using only constraint layout. Don't put additional nestings to it. And then the animation should work. A little heads up, you should be a little careful when you're working with scroll view and collapsing toolbar coordinator layout. You need to put additional efforts to achieve this method, but you can switch to another method which can probably work for you. This requires a little bit more work. And let's look at this example. In this example, we'll be dealing with 3 frames. So the first frame, everything is in the normal position, the Java and Kotlin. On the second frame, you'll have the explanation for Java. And the third frame, you'll have explanation for Kotlin. And you get that animation. Here in the blueprint, you can actually see those text view visible, whereas the preview, you'll not be seeing the text view. It's probably because I've used alpha. When you set alpha 1, it's visible. When you set alpha 0, it's not visible. But there is an important concept here that you need to grasp. When you look at the blueprint, the text size of Java and Kotlin are different. Java is a little smaller, and Kotlin is a little bigger. I'll give you some time to grasp that. So when you look at the actual animation, the text size of Java and Kotlin are the same. Yeah, some people got it. So why is this happening? I exactly directed the second frame should look like that. But why is that not reflecting in the animation? So the problem is the constraint set animation works only for layout-related attributes. Text size it has some impact on the layout, but it's not exactly the layout-related attribute. So height, width, exact for the image, the Kotlin is bigger, the Java is bigger. So image, it works because height and width are layout-related attributes. But the text size isn't the layout-related attributes. You need to set programmatically if you want to create the transition using the text, actually. And also, it is better to put all the stylings into the first frame. In the second frame, you just have to define the constraints properly. You need not replicate with stylings. For example, you have created a layout, and you have created another layout for animating. Later on, when there is a future development where you need to modify the styling of certain things, you need not do it in both the files. You can just have to do it in the first file. So the second file doesn't hold the styling attributes. It holds only the layout-related attributes for the animation. So exactly, so you can forget about changing the same thing twice in both files. Unless until if it's a rearrangement, probably you should change, but not the style. And let's take another example, the speaker profile example. The first frame, you have the image view occupying the full screen, pushing all the views to the sides. And on the second frame, it pushes all the view inside. And that's how this animation actually comes. So trust me, when I was experimenting these methods, it was somewhat similar to do a presentation. Like you put 2 slides, and you click both slides, animate, initiate a transition. So that is also a keyframe, and this is also a keyframe. And let's see what other transitions are available to us. The API provides default transitions, such as this, the bounce, the cycle interpolator, decelerate interpolator. So these interpolators is nothing but the rate of change of animation that's happening. And there is a function called, a class called change bounce, which will measure the initial and final frame values that it has to initiate the transition. And you can use somewhat like this. So you use a transition, you get the change bounds, and then you apply that particular interpolator to it so that it acts. So the examples that we saw, Java and Kotlin example, it kind of had a pop effect. So that's overshoot interpolator. So finally, some heads up. So the constraint layout and constraint set animation, the constraint set, it works from API 9 onwards. But the transition manager is from 14 onwards. But the devices with 13 will not have the exact animation because all the styling is in the first frame. If you really put it in the first frame, then it will work as it is without the animation. And you need to be a little bit aware of nesting layouts. When you nest too many things, it will not be a straightforward method. You might have to programmatically do it. And the load method currently has an issue. The tracker has been open. And the problem is when you provide constraints like start and end, it doesn't work. But when you provide left and right, it works. So you need to be a little beware of that, but they have promised that they'll be fixing it in the next beta release. And let's recap finally, so to get things all in the order. So this constraint layout and constraint set animation works just like the keyframe animation, where you need to create 2 layouts or n layouts, how much ever animation we want. Then we use constraint set to absorb all the mappings, and by using clone and load method. The difference between clone and load method is that it inflates and absorbs. Load actually just parses the XML. Little heads up because it has some issues. You have to use constraint left and right instead of start and end. And we use transition manager to help us with the animation. We can use our own animations and interpolators to give jazzy effects. And then we use constraint set.apply to apply the constraints respectively. And if you're worrying about duplicating the layouts, you're not exactly duplicating the layouts. You're creating another layout to absorb only the constraints, not the actual styling attributes. Yeah, so styling attributes, you have to entirely dump this into the first frame, not on the second frame. And it works from API 9 onwards. Transition manager, it works from API 14 onwards. So here are some of the resources that I can share you with. So all the examples that I shared right now will be available in this GitHub project for you to try it out. And few things you'll find it in Java as well. Then there is a Medium post that I wrote, 3 Medium posts regarding this entire animation plot. And there is a nice video by Scene where you can actually view the entire overview of this in a single 2-minute video. And there is a nice Robinhood engineering post, you should check it out, where they have created this animation for the checkout process, where only in the checkout process you will have minimum elements, and that will be animated pretty quickly. And yeah, so thank you. Thanks for your time. And if you are building any layouts, feel free to send it to me in Twitter. And I'm open to questions now. Yeah, please.
Just a quick question about the load problem. Can you use both left and right and end and start, and it works fine if you use both?
I did not use both, but I used one of those. It didn't work. And probably, I think, when you're dragging and dropping, it automatically takes start and end. So you have to switch back to the XML and change it, which actually it spoils the method. So I did not try that. But yeah, of course, maybe both would work, but it would take preference of start and end depending upon the API that you're configuring the project with. So that was a problem.
Is there a way to get the constraint set without actually building a layout, programmatically build just the constraint set for that second layout?
Very good question. No, I haven't not. But again, that will actually spoil this method because it has to be quick and everything. But for a single view, as I showed you, you can actually set the constraints programmatically. It's a lot more better. And this method will be a lot more effective when you want to animate many views in a single event. Like when you're opening, you have all from the left to right, it comes from the bottom, it comes. So those methods will be a lot more effective when you prefer this method. Did I answer your question? Yeah, thank you. Any more questions? Yeah.
question. If is this method still in beta? And if so, how likely is the API going to change for doing the transition set and all the stuff?
This API, you mean there are two
the whole
APIs we are dealing with here, the transition manager and
Yes.
constraint layouts. So constraint layout is changing a little bit. I mean, they are bringing more flexibility in and as well as bug fixes. And some of the feature requests are genuine. They are considering that as well. So that is coming. But the only advantage of this method is very less code. And probably when you have something addition, probably it'll add a couple of lines or something. And transition manager is a little bit stable. And they have default transition, the interpolators that they have given for you. And additionally, probably a new interpolator may come, or the transition manager behavior might change. And apart from that, that's quite stable.
Yeah, but the whole dance of cloning the first constraint layout and then loading the second one, that's going to be stable. That's stable. That's how it is.
Yeah, that's how it is, because it's a keyframe animation. You need frames to perform the animation.
Okay, recently I did an animation that involved changing the text size, and you alluded to that earlier, that changing the text size is a little bit different.
Yeah.
And to make a long story short, I had to resort to converting the text view into an image view and then scale it.
Okay.
And then convert it back to a text view after it was all done. It was kind of ugly, and I'm wondering if you've encountered this situation and come up with an alternative approach.
Well, alternative, I just showcased a way to set the constraints for the text view recently. If I could go back on that. Yeah, so here, this text view, I'm setting the width as 200. So it increases.
Actually, I'm talking about the text size.
Exactly. So when you have different size, then you can programmatically set the text size.
Okay.
You can programmatically initiate a transition and set the text size. That would actually work, because text style comes once again in a styling attribute, and these will absorb, reflect everything in the layout related attributes.
Hi. Do you have a rule of thumb of when to use constraint layout compared to the usual way of doing animations?
You're asking rule of thumb for using constraint layout or this animation?
The question is, in what cases will you use
This
constraint layout?
animation.
Yeah.
So as I said already, it's like when you have many views that you want to animate on a single event. For example, when you're tapping on a button or opening the particular activity, you need all views to animate some kind of an animation. But don't over animate as well. As per the UX guidelines, and the best practice for the animation is the user shouldn't be feeling the animation. It should go with their natural movement. So when you animate multiple items in a single flow, yes, obviously it will work. So for that, this animation can be used. Plus time constraint, if you want to do an animation quickly and forget about the math, and as well as whether this animation will work for different screen sizes that you're dealing with, you can use this method, because constraint layout automatically solves and matches the particular screen size, whichever you're working with. So that tension is gone. And yeah, you can just quickly do it and take care of what's really important. Of course, animation is important, but it's always the last minute work, and probably people would start animating only after the beta releases or something. So yeah, you can save a lot of time with this method. Did I answer your question? Thank you.
Yeah, I still have some concerns about duplicating the layouts. Let's say we have some views in the constraint layout that have nothing to do with the animation, they're just there. And then if I need to make a change to those, I will still have to do that in both files.
Yeah,
right?
you have to. So for example, when you're rearranging things, you have to change it. And when you're entirely changing the arrangement, because that changes will come frequently in the real time, I understand, you have to redo it. But if it is cosmetics like stylings and those attributes, you can just do it in the first frame. But of course, you need rework when you're actually changing, because that's the requirement that will frequently come when we are working in real time.
So there's
Yeah.
no way around that, right?
Yeah, that's no way around, because it's, once again, it's a keyframe animation. That's this method. So you can actually calculate the amount of views that you're actually having in a layout. The Robin Hood engineering, the post that I mentioned in the resources, they used checkout, for example, where all you have is a credit card and you have some swipes. It all comes into a single screen without scrolling. And same way, the product detail page. And those are the places where you can give some beautiful experience to the people. And checkout is really an important step. You actually have to make him pay for your product. So those are the places where you can do this more beautifully than depending upon other methods. So here it works. In other method, you might have to put additional effort, calculate the math, and do it. So you have to decide on where you want to actually use this animation. Yeah, true. Any more questions? So thank you. Thanks a lot for your time. Thanks for joining.